Batch reactor overview. This video will contain some basic information on one of the most commonly used reactors for a variety of different products, and will explain when you would and would not use a batch reactor. Assumptions that are commonly made for a batch reactor is that it is contained in a closed system. We also assume that the reactor is well mixed, and therefore concentration and temperature do not vary throughout the tank. Cooling in a batch reactor is done using an external heating jacket. This controls the temperature of the reactants in the case of an exothermic reaction. Scale-ups for batch reactors are usually quite simple. For both isothermal and adiabatic systems, in which no heat is added or removed, the system easily scales up with volume. The main difference in scale-up of batch reactors is in terms of heat transfer. As you increase volume, your surface area does not increase as quickly, and therefore there is less room for heat transfer. If we start with a reactor with a diameter of 1, whose volume and surface area are also 1, when we increase that diameter by a factor of 10, our volume increases by a magnitude of 3, and the surface area only increases by a magnitude of 2. Using a standard A to B system, we know that the total moles of species A per time is equal to the rate of reaction times the volume. Given a rate law, such as this second order one, we can then substitute into the original equation and get that dNA over dt is equal to negative Ka times Ca squared times the volume. In a batch reactor, the volume does not change, so V is equal to V naught. Noting that Na is equal to Ca times the volume, we can then see that the volume terms cancel out. This leaves us with dCa over dt is equal to negative Ka times Ca squared. This clearly demonstrates that volume does not play a role in the scale-up process of a batch reactor, but concentration does. So why would you ever want to use a batch reactor? In the case where you have small-scale production, such as dyes or drugs, when you are using a new process or an untried reaction, when the material of use is of high value, when a long reaction time is needed, or when contamination or fermentation occurs easily. When would you not want to use a batch reactor? When the materials used cause poor mixing in the system, when there are risks of impurities. A batch reactor contains heat transfer limitations and results in a longer startup time. Also, if the materials used in the reactor have catalytic properties, a batch reactor would not be good to use.